Are you satisfied with the Copenhagen interpretation of quantum mechanics, as it's the most successful uh, notion of the theory till today? Or do you consider the many worlds interpretation to be a bright prospect? So the Copenhagen interpretation is the great victory of Niels Bohr over Albert Einstein. There was this great set of debates these two uh, towering scientific, towering physicists had in the 1920s and 30s. I don't remember the exact time frame, but they had these debates about the meaning of quantum mechanics. So when the this new science emerged, quantum mechanics, it was all bits and pieces. They were trying to put things together, they were trying to understand what it is telling us. And slowly, first you had the notion of the quantum, that energy is quantized, that you have a quantum of light called the photon. Then you had the then you found it was found that energy levels in atoms are quantized. The atom was discovered, electron, proton, neutron, etc. Then there was the Bohr model of the atom, and so on and so forth. But the question was, what does quantum mechanics tell us? There were these great paradoxes. You had wave particle duality. Particle of a particle can be a particle, it can be a wave at the same time, right? A photon is a particle as well as a wave, and so the same for any other particle, right? So you had this thing. Then you had the problem of the collapse of the wave function. A particle doesn't have any properties when it is not being observed. It is just a set of probabilities. So these properties are meaningless unless you observe it. It doesn't even exist in one place at the same time when it is not being observed. And when you make an observation, when you make a measurement, the wave function of the particle collapses into one single state. Before that, it was a superposition of states. So the Copenhagen interpretation of quantum mechanics says that the properties of a particle have no meaning before a measurement is made. It's just a set of mathematical probabilities. So a particle, the properties of a particle are meaningless until and unless you make a measurement or an observation. And Albert Einstein was against that. He said that properties should exist, and he proposed a number of other alternatives. So according to the Copenhagen interpretation, particles, the measurement or observation of a particle causes the collapse of the wave function, and before that the particle doesn't really exist. It's just a set of probabilities, and it is best expressed in this famous line: shut up and calculate. Don't ask philosophical questions of what the particle was doing before you observe it. Just calculate, use the laws of quantum mechanics to calculate uh, whatever you're calculating, and that's how you make progress. And that's how all the quantum mechanics based technologies have evolved that made the 21st century possible. So it's been a very successful interpretation. Most physicists believed in this interpretation until recently. Now you have more and more physicists who are leaning towards the many worlds interpretation, which is due to Hugh Everett, uh, who was a so Hugh Everett is the physicist who put forward this competing interpretation of quantum mechanics, which says that every time a measurement or observation is made, the wave function seems to collapse, but it's actually branching off into two different paths, in two parallel universes, into parallel worlds. So what you see, the collapsed wave function, is what you see in this specific universe. But in other branches of the timeline of the particle, the other possibilities are still present. So every time you make an observation, the world splits off into two universes. Every time you think about something, every time you make a decision or a choice, every time you flip a coin, the world splits into two branches. So that is, in very brief and very roughly, the many worlds interpretation of quantum mechanics. It is physically consistent. There is nothing wrong with it if you examine it properly and deeply. So what is my stand? I think the many worlds interpretation is very interesting. I think the Copenhagen interpretation is limited. I am sure that there is more to quantum mechanics than just a set of probabilities of a particle when it is not being observed. There has to be something more. That's my gut feeling, and that's the gut feeling of many physicists. So I would think that the many worlds interpretation is very interesting, and it should be something that should be investigated further. So I am not firmly in favor of one or the other, but I think the many worlds interpretation is very interesting, as are some other interpretations of quantum mechanics. The Copenhagen interpretation has been very successful in taking science forward. It's been successful in putting away the philosophical questions and just calculating and making further discoveries. So, from that perspective, it's been brilliant, but there are many unanswered questions, and those have to be addressed. And the many worlds interpretation is one step in that direction. I think a lot of ground needs to be covered, but that's where we are today.